Here's our last lesson on discrete random variables, and we're going to learn about the binomial distribution. So reviewing a discrete random variable is x is the number rolled. If x is the number rolled with a die, you might be asked the question, find the probability of x being greater than 4. And so x has the values of 1 through 6. But today, with a binomial distribution, a similar question, a die is rolled. Find the probability that 1 is rolled twice out of 10 rolls. And so this is what a binomial distribution would represent. And what is different about this is that it's either a 1 or not a 1. And so we don't care about, in this one we look at all the possible values, and here it's just a 1 or not a 1. And so that's having only 2 outcomes. We also have to look at there's a fixed number of trials, and the probability always has to be the same. So we want to look for only 2 outcomes. We always have the same probability, and there's a fixed number of trials. It has a mean of NP, where P is the probability of the outcome, and the number of trials. That's the mean. Standard deviation is NPQ, and Q is just if P is the probability of success, then Q is the probability of failure. So we just go NPQ square root, and we get the standard deviation. So here we can have a binomial distribution rolling a 6-sided die. If we look at a win being a 1 or a 2, that would mean a loss is any of the other numbers, and we're going to roll it 3 times, find the probability of 1 win. So we have to be able to represent this with a formula, and also how to do it on the calculator. So the probability of success is a 1 or a 2 out of 6. So that's 2 out of 6, or 1/3. And the probability of losing is 2 out of 3. And N is 3. We're going to roll the dice 3 times, and we want to find the probability that we have 1 win. So the probability of 1 win is going to be, and now we use the formula from binomial expansion, where we have n choose r, so we have 3 choose 1. We'll have the probability of a win, and the number of wins, and the probability of a loss, and the number of losses. So if we're going to roll the die 3 times with 1 win, that means we have to have 2 losses and 1 win if we're going to roll it 3 times. So here's how we can set it up and do it by hand. And then we can also look at the calculator notation. So 3 choose 1. This is, see the connection to Pascal's triangle and binomial expansion. When we have 3 choose 1, or we can say n choose r, 3 choose 1, something like that. And we calculate it with factorials. So the value of 3 choose 1 is this is 3 choose 0, 3 choose 1, or 3 choose 3, 3 choose 2, 3 choose 1. Either way, the value is going to be a 3. All right, so we get 4/9. The probability of 1 win, 4/9. And on the calculator, we do binom this is going to be a PDF. Binom PDF, if it's x equals 1, we use binom PDF. If it's x is less than or equal to a number, we use binom CDF. Binom PDF, that's second vars binom PDF. And we have 3 trials. Probability of success, 1 divided by 3. We want 1 success. Paste. So if you don't have this display on the calculator, then you would have to enter it like this. Binom PDF, and it's going to be NPX. Number of trials, probability of success, and the number of successes. Binom PDF. NPX. Number of trials, probability of success, number of successes, and we get 4/9. On the IB test, don't write this. You would want to just write, if it's on the calculator part, you can just write this and then write the answer. If it's on a non-calculator part, then you have to show that work. Find the probability of 4 successes out of 7 trials if the probability of success is 1/5. Okay, pause the video and try that with no calculator and with the calculator. So we have N is 7, P is 1/5, and Q is 4/5. So without a calculator, we're going to do probability of 4 successes is N choose R, 7 choose 4. The probability of success to the 4th power, because we want 4 successes. The probability of failure to the complement of that. And with a calculator, binom PDF, it'll be N P X. And just a reminder, this would be 7 factorial, 7 minus 4 factorial, 4 factorial. So that's what that means. We have that to review, and then we can just calculate. I guess that would pretty much be a calculator problem anyway. But if we have a graphing calculator, we can do it this way, and we should get 0.028. Find the probability of 3 failures out of 8 trials if probability of success is 2/3. All right, be careful on this one. Pause the video and try that. So we have to be careful because it's asking for failures and then the probability of success is given. So we could switch it around and say we want 5 successes. If 3 failures, then 5 successes. We could do that, or we can just make sure we have the exponents correct. So without a calculator, the probability that x equals 3, if we're looking for failures, we could say that that will be 8 choose 3. But now, if the probability of success is 2/3, the probability of failure is 1/3, and we need 3 of those. So then we have 2/3 to the 5th. So that's how we would set it up. Then on the calculator, binom PDF, n is 8. P, we would have to say it's 1/3, and then 3 for the number of those occurrences, and we would get 0.2731. Find the probability of less than 3 successes out of 7 trials if the probability of success is 1/5. Now this is looking at multiple possibilities. Previously we wanted exactly X outcomes. Here we want 3 less than 3. That means it could be 0, 1, or 2 successes. If we were doing it by hand, it would be the probability that X is less than or equal to 2. You could also say the probability that X is less than 3. These mean the same thing. And this is going to be important when we look at the calculator. That's the probability that X equals 0 plus the probability that X equals 1 plus the probability that X equals 2. So doing that by hand would be a lot of work. We have to do this formula for each of these. But on the calculator, we'll use binom CDF. And for CDF, we have to have that symbol less than or equal to. That's what this is programmed to use. So if I put a 3 in, it would be incorrect because it's less than 3. We need less than or equal to. So binom CDF, it'll follow the same notation where we have n, p, and x is 2. So it does all the calculations, and we would get that. Find the probability of at most 1 win out of 6 trials if the probability of winning is 3/5. All right, pause the video and try that one. So we have to be careful. At most 1. Some people have trouble visualizing what the at most, at least, or more than, less than. So at most 1 means it could be 1, but it can't be 2 because the most it can be is 1. So that means it's going to be 0 or 1 would be the 2 possibilities. So if we were doing it without a calculator, the probability that x is less than or equal to 1 is going to be the probability of x equaling 0 plus the probability of x equaling 1. So with the calculator we have binom CDF in P and X is 1. And we should get 0.041. Find the probability that X is greater than 5 if n equals 10 and the probability is 1/3. So maybe we'll have another question that looks like that. So this is our main concern is this symbol. We can't use a 5 in the calculator, and we wouldn't want to do this by hand, so we need to rearrange that. We want the probability of what's more than 5. That means we don't want 5 or less. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want X to be greater than 5. We want all of these, the probability of any of these occurring, these number of successes. We don't want any of these. So what we can do is have 1 minus the probability of X being less than or equal to 5. We have to have that symbol less than or equal to use the calculator. So we'd have 1 minus binom CDF, and that's going to be n, p, and x. Oh, look at that. It turned out we would have gotten it right, except if we just put a 5 in there, we wouldn't have the 1 minus, so we would have the complement of what we wanted. And we get 0.0766. Find the probability that X is greater than or equal to 3 out of n trials with a probability of success of 4/5. All right, pause the video and try that one. Out of 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. We want it to be 3 or greater. We want this. That means we don't want 2 or less. So now we have to be careful here. In the previous problem, we were able to keep the same number, but in this one we have to go down. X is less than or equal to 2. We don't want the 2 or the 1 or the 0. Probability that X is less than or equal to 2. And we'll have 1 minus that. So 1 minus the probability of what we don't want will equal what we do want. And so now we're going to have 1 minus binom CDF in P and X. So 1 minus that, and we should get 0.9988. And let's just check this one up here, and we can see how to do that on the calculator. 1 minus, and then we go second vars binom CDF trials 10 1/3. All right, so that's what we have there. And then I think that'll be correct too. And we'll stop there.